Hello world, Paul Whittakin again, returning to you from the University of the Universe and the Universal Law of Numbers. So, I'll try and arrange this thing so you can see it. That should be better. Okay, so basically what I want to do is I want to recap a couple of things and I want to reinforce a couple of things here, but the main thing I want to say today is, you can really forget about me because this is not really about me. What you can do is you can write your own code of numbers, copy the code, and you can explore it. And the more that you do explore it, the more amazed you will become. But I will just kind of help to get you started. So for people who are new, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. It works like that. Nothing against 11, 12, or 13. It's just for the purposes of the organization and the structure of the numbers in the universe, they all reduce down to single digits, and then things start to make more sense because of the simplicity of it and the synchronicity of it and the, what is that word again? It is the symmetry of it. Okay. So, now you can learn a lot from this and it can help you with a lot of things, but we have this 248751 code, and it's over here 224871, and it's in here as well 248751. Now you just saw how I did that a little differently that time, and it's okay. There's a reason for that. It belongs there. All of the numbers belong exactly where they are, and this is not a creation of mine. It is a discovery. And what I've discovered is everything about it is perfect. So I've even referred to it as the God number. And truthfully, it's the closest I've ever become to God in my lifetime by discovering this thing. So it can be used for great good. I'm sure it can be used for evil purposes as well. I don't, promote that. And I think if you were to use it for evil purposes, you would be messing with the universe. You would be messing with the creator of the universe, and it might not work out so well on your behalf, I would assume. I have intuition with this thing, and my intuition has served me correctly, for the most part. I'm just learning. But anyway, we're going to cover a couple of those things today. So we have the 417 and 714 code. They're both the same code. The 714 417 code is, in essence, it's the 258 code. In essence, it's the 369 code. It's just how the numbers 3 and 6 add up to 9, okay? In the case of 258, 2 plus 3 is 5 plus 3 is 8. In the case of 147, 1 and 3 is 4, plus 3 is 7. But it continues on because 7 plus 3 is 1, plus 3 is 4. And also we understand that addition is the same basic, it's the same property that multiplication is. So it would have to work multiplying as well. So 4 times 7 is 28 is 1, 4 times 4 is 16 is 7, 4 times 1 is 4, 4 times 7 once again is 28 is 1. Or 7 times 4, 28 is 1, 7 times 7 is 49, which is a 4, and anytime you have a number together with 9, it will reduce to that other number. So in that case, it's 4. 7 times 1 is 7, and 7 times 7 is 4. So that revolves around, and it continues forever as well. You can get these codes many different ways inside of this because it's a perfect number. If we add up, for instance, 1, 4, and 9, like I say, whenever you have a 9, you can ignore it. 5, 9, 8, 6, 2, 3. Okay, so 5 separated by 9 is an 8. then you have the 6 number, you know, that's a 9 number, and then you come with 2. So 2, 8, 5, 5, 8, 2. It's actually so mind-boggling that you really need to do it yourself. And I highly recommend it. I think there's a lot to gain from that. So to recap a couple of the things that I've covered, I covered basically what I'm saying about this thing is it's a universal number. And inside of this universal number are embedded other universal numbers. And I've pointed out that the Fibonacci series is embedded inside of here. Recently, I pointed out how 2 pi is embedded inside of here because it's the circle. But really, this is a multi-dimensional circle. It's a sphere because we have, it goes to different powers. We square it, we cube it, we take it to the 4th, 5th, 6th, 7th, 8th power to infinity power. So that I envision in my mind as some sort of a sphere. Okay, so it could very well be the equation for a sphere. And we have an equation for the sphere, but this is a numerical equation. Another thing about this is you don't see any symbols. They're not necessary. We can use symbols. We can square 4 and come up with 16, and then we can take the radical, put it under a radical sign, and come back right up to 4, but it's not necessary. Mathematics can be very confusing when it's all a bunch of, symbols which all mean something, not to discredit it, but it can lose its simplicity and appear more complicated than it is. Okay, so what I'm going to do is I'm just going to recap a little bit to demonstrate once again how the Fibonacci numbers are inside of here, how 2 pi is inside of here, and how pi is inside of here as well. Because if 2 pi is there, then pi has to be there too. So I demonstrated with this by just writing down the Fibonacci numbers, and I reduced them, and I came up with this. And basically it shows that we have the sequence 3, 3, 9, 6, 6, 9, which continues 3, 3, 9, 6, 6, 9, 3, 3, 9. Okay, that continues on forever. The numbers are separated by 4. And also I demonstrated that the Fibonacci code, besides the 3, 6, 9, well, really if you have a 3, 6, 9, then you have to have the 2, 4, 8, 7, 5, 1, because 2, 4, 8, 7, 5, 1 is 3, 6, 9. It's the numbers that are between 1 and 9 that are not 3, 6, and 9. But, 3 goes between 2 and 4, 6 goes between 5 and 7, and 9 obviously goes between 9 and 1 again, or 8 and 1 again, because it starts all over at 1. Okay, so not meaning to confuse you, but just to elaborate on that a little bit, because what may appear to be true is actually simpler than it appears. Because if you look at the Fibonacci sequence, you understand that it goes on forever. And it does. But it follows this sequence. It follows 3, 3, 6, 3, 3, 9, 6, 6, 9, 2, 4, 8, 7, 5, 1. 3, 3, 9, 6, 6, 9 with the 2, 4, 8, 7, 5, 1. That's just what it does. And that's what we find here in the universe. Okay, so what about pi? Well, pi has been a very elusive character in the history of mankind because it appears to be also a number that's an endless sequence that doesn't seem to follow any kind of, structured sequence. But in reality it does, and I'm going to demonstrate that for you as well. Now, I started off by doing, here's just more Fibonacci. It goes on forever. Just try it yourself. It's a lot of arithmetic, but once you get the sequence, you can rest assured that it will follow on forever because it's just the way the universe simplifies it for us. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all it is. Okay, so I talked about, in a recent video, I talked about 2 pi. And I took out this thing here, and I show that 2 pi follows the sequence like this. 2, 4, 8, 7, 5, 1. Well, you might ask, why does it follow 2, 4, 8, and I do 7, 5, 1 like that? Well, because I didn't create it, I just observe it. But we will see it here in the code, and I'll show that to you right now. We have it right here on this line. It's 2, 4, 8, 7, 5, 1. Okay? And it's in a very ideal position right there in the center. And this is a very important number, obviously, in the universe. It's 27 squared. You know, 2, 7 is a 9. It's one of the 9 sequence because 9 times 9 is 81 times 9. Well, 9 times 81, 729. Okay, that's what it is. You get it right away. Now, so basically what I show here is 2 pi follows this sequence. 9, 3, 6, 9, 3, 6. But folks, we can also say 3, 6, 9. And if we go 3, 6, 9 like that, then we're going to go 3. Well, let's start with the 1. 1, 8, 6, 4, 2, 9, 7, 5, 3, 1. Okay, so in that instance, it's 2, 4, 8, 7, or 2, 4, 8, 7, 5, 1. So 2, 4, 8, 7, 5, 1. If you want to look at it like that, you can. You can look at it any way you want, but it's embedded in the code. Basically, pi, a derivation of pi is embedded in the code because the code encompasses the entire world of numbers. Because all numbers have to be in their place, assembled according to the structure of this universe. This is not only a universal number like pi, this is actually the universal number because it has not only 2 pi and pi embedded in it and all, you know, multiples of pi. It has all of the sequences in there. You know, I haven't checked everything out yet, but I have a fairly, I have a very strong suspicion that when I say things like that, they're going to, be true because the thing has that quality about it. That's why it's so profound, okay? It appears simple, and that's the beautiful thing, but in reality, it's very, very profound. So I just showed you the Fibonacci numbers, how they're found inside of the table, and I just showed you how 2 pi, which is the circle, is embedded inside of the table as well. The universal number, I think of it as one number. It's one constant that will always be a constant, just like 1, 2, 3, 4, 5, 6, 7, 8, 9 will always be a constant. So will this, and it can never change. Now we're going to talk about how do we arrive at pi, or how do we bring pi into the picture. Well, it's quite easy, actually. Now, this is 2 pi following that sequence. 2, 9, 7, 5, 3, 1, 8, 6, 4. That's just the way 2 pi is. That's the number it is. And we showed it to you over here. 2, 9, 4, 8, 9, 7, 9, 5, 1. Okay? Now, the thing about the 3s and the 9s are, one of the things that we have to understand in order to understand not only the periodic table of mathematics, but what numbers do. Okay, so numbers have dual personalities. They even have more than dual personalities. I'll just give you an example. If we take the number 11, it's an odd number, right? We consider that an odd number. But if you go 1 plus 1, it's an even number. So already, it has a dual personality. The only numbers that don't have a dual personality is when you do 1, 2, 3, 4, 5, 6, 7, 8, 9 by themselves. Before they turn the corner at 10, they're going to have their own personality, which is, it's actually shown here in the first line, because This first line, among other things, it shows you the odd numbers followed by the even numbers. You may not see that, but I'll do it for you. 9 to 1 is 1. 1 to 4 is 3. 4 to 5, 4 to 9 is 5, and 9 to 7 is 7. So those, if you want to go from 9 to 7 is 9. So those are the odd numbers, 1, 3, 5, 7, 9. Then we're going to get the even numbers. 7 to 9 is 2, 9 to 4 is 4, 4 to 1 is 6, because 4 plus 6 is 10, and 1 plus 8 is 9. So now we just got the odd numbers and the even numbers, and this is what this thing does. It points these things out to us if we care to look a little bit deeper. Now, we're going to do pi right now. I'm going to show you how pi is also embedded in the code. So, is it fair that pi is half of 2 pi? That's a mathematically allowed operation. So if we divide 2 pi by 2, then we're going to get pi. So what I did was I just divided these numbers along this side, which are 2 pi, and I put their equivalent on the other side underneath pi. So if we divide 2 by 2, we get 1. If we divide 9 by 2, we get 4.5, which is a 9. If we divide 7 by 2, we get 3.5, which is an 8. If we divide 5 by 2, we get 2.5257, right? If we divide 3 by 2, we get 1.5, which is a 6. If we divide 1 in a half, then we get 0.5, which is a 5. If we divide 8 by 2, it's a 4, 6 by 2, it's a 3, and 4 by 2, it is a 2. So pi follows the sequence 1, 9, 8, 7, 6, 5, 4, 3, 2. Okay, it's just what it does. But we have that here too in the code. But I do want to point out again that 9, 4, well, especially 3 and 6, let's say, they have the dual personality where they turn into 9s. Because 3 times 3 is 9, times 3 is 27 is 9, times 3 is 81 is 9, times 3 is 243 is 9. It's always going to be a 9 once you get past its, initial personality of being a 3. The same thing applies to 6. 6 times 6 is 36, which is a 9. 36 times 6 is 216. Yeah. 216 is a 9. Times 6, 216 times 6, I guess it's 1296. I'll check that later. Don't worry about it. It's a 9, okay? And it will always be a 9. You're going to go on forever. It'll always be a 9. Okay, so we find pi here in this sequence. So I will pull this thing from behind. So we have, forget about the 963 right now. I'll just go 187542. 187542. So that's where you find pi in the table, and it's separated by 9, 6, and 3. It's separated here also on this line, on this line, on this line, 3, 6, 9. Now, it's just the derivation. See, I didn't create this thing, and it's beyond my ability to create such a thing. Such a thing can only be created by the universe, and I was just lucky enough to discover it, and I was aware enough to understand that this discovery is something that's it's a scientific discovery. It's a mathematical discovery. It's truly a very profound thing, and whatever the applications of it are, they can be quite, infinite. Infinite possibilities, infinite applications, and I hope, as the world continues to turn, as this universe continues to spin around, that people can put it to good use, because I can imagine, so many different good purposes. It can be put to so many different good purposes. I've spoken about it in terms of science, whether it be physics, chemistry, biology. I've spoken about it in terms of all of the humanities. And you can even speak about it in terms of religion, because we have 3, 6, 9. Let's just say that's God the Father, God the Son, God the Holy Spirit, and there's one God. Okay? But this is not religion I'm talking about. I'm really more referring to my concept of God. I'm not going to try and recruit anybody to any particular denomination or faith or anything like that. I think this thing can do, it's more powerful than that. It doesn't have a religion. It's just looking straight in the eyes of God. And God can talk back to you. And God can teach you something. So that's just the way I look at it. Call it what you will. Call it the universe. It's okay with me. Now, there are lessons to be learned about it as well, because it's teaching us, there's a message of unity. And right now, as I speak, we have people with itchy fingers on atomic bombs and all of this kind of thing. It's all a very, horrific thing. If you study this a little bit and you gain any wisdom and knowledge and truth from it, you'll see that it's just, if it's God, if it's the universe, it's one God. It doesn't care if you live in North Korea or Yemen or Syria. It doesn't care, if you live in the United States or Russia. It doesn't care anything about that. It's just speaking to us in the universal alphabet of 1, 2, 3, 4, 5, 6, 7, 8, 9. So to all of the people out in the world, I wish everyone peace and happiness, and I'm signing out for today. Okay, until next time. Bye. Paul Whittekind.